Now, we will going to take up one more problem on projections of points. The problem reads as: a point is 20 mm behind VP lying on HP and 35 mm in front or behind or from RPP. Draw its projections and name the side view. Hitherto what we were analyzing the problem is on totally on exclusively in first quadrant, in second quadrant, third quadrant and fourth quadrant. In this case, if you observe here, a point is 20 mm behind VP. So behind VP is condition, it comes in second quadrant and also in the third quadrant. If the point is behind VP and above HP, then it lies in second quadrant. If the point is behind VP and below HP, then the point lies in third quadrant. But the condition given here is lying on HP. Since it is lying on HP, either it can be in the second quadrant or it can be in the third quadrant. In such a case, what we need to do is we have to observe the condition of behind VP. Behind VP will be there in second and as well as in the third. So therefore, you will be able to get the quadrant in the second and in the third quadrant. If you are considering that, then you have the 35 mm in front or behind or from RPP. If you are considering that, then it will be behind VP, so it should be behind RPP because behind VP is the condition. So if it is behind VP, then what we will go, let us see how it will going to analyze this type of problem. First, we will consider the quadrant which lies in the second. When we are considering the second quadrant, VP, that is the vertical plane, is here, and HP, that is here on the horizontal plane, and this is the right profile plane. So when you are considering that, if you are looking from the front view, the point is lying on HP. So you can see that point small p is lying on HP. So when you are looking from the front view, it projected onto the vertical plane. So that means the point P will be lying on HP. So that means it is on the XY line. And behind VP, when you look from the top view, you can see the distance behind VP, which is 20 mm. And that you can see when you look from the top view, it will be on HP and it will be a small letter P. And the distance 35 mm in front or behind or from RPP. Since it is behind VP, obviously it should be behind RPP. So when you look from the right side view, the point is behind RPP, so that is this point. And then when this behind RPP can be seen in the vertical plane, when you look from the front view, you can see the distance. When you look from the top view, you can see that distance. Now how to rotate this now? When you are cutting it and opening it out, HP will be rotated to the top and RPP will be rotated in the clockwise direction. It will be aligned with the vertical plane. So that we can see in the step 2. So here both VP and HP will be overlapping with each other. Since HP is the plane which is being rotated, therefore it has been shown in the bracket. So the correspondingly the images on those particular planes will be automatically being rotated. So we can see when you look from the front view, the distance with respect to the profile plane, that is 35 mm behind RPP, is taken in both VP and HP. Since both VP and HP is above the XY line, so from here you measure that 35 mm, you will going to get this. As it is lying on HP, suppose if it is above HP by 10 mm, what happens? This point P dash, which will not be on this line, instead it will be above, that is 10 mm above this. Suppose if it is 5 mm above HP, then that point will be from this line, it will be 5 mm above XY line. As the distance with respect to HP is reducing, the point is tending towards the XY line. So since it is lying on HP, so obviously that point will be on this XY line, which will be P dash, because the image falls on the vertical plane. And we know that behind VP is seen in HP. Since it is being rotated by 90 degree, then P dash and P both will be on the same line. So from here you measure 20 mm and mark this point small p. As we see in this right side view, the distance with respect to HP and also the distance with respect to VP can be seen. So we can see, when you look from the right side view, I can see the distance behind VP, which is 20 mm, which will be seen here. Since it is lying on HP, so obviously it will be on this line, XY line. So as we see here, since it is lying on HP, so obviously it will be on the XY line here. Then we know that behind VP distance of 20 mm, so when it is projected till here, you will be having the 20 mm in the vertical direction. And this 20 mm vertical direction has to be transferred to the horizontal direction. So by drawing at an angle of 45 degree, what happens from this point, by drawing a line at an angle of 45 degrees, then what happens, the distance of this vertical distance of 20 mm is transformed into the horizontal distance. And where you have the front view, on that line only you will going to get the side view. So that is also, it is evident from in the second position, in the first step, wherein this P double dash is on XY line. As it is cutted and open, this P dash will become the horizontal direction. Since it is behind RPP, so obviously what you will going to get is the right side view. Now we will going to take up the orthographic view of this, how to draw it in a sketchbook. So first you draw the XY line and X1Y1 line. Then as we know, the distance with respect to the profile plane, that is 35 mm behind RPP, is seen in both VP and HP. So once you draw the X and XY and X1Y1 line, then identify the plane first. So that means first you write VP and then you write HP, and RPP adjacent to VP only. Since VP is above XY line, RPP is also above XY line. The distance with respect to the profile plane, which is 35 mm, is seen in both VP and HP. So from X1Y1 line, you measure the distance of 35 mm and mark a thin line, because this is a projector line. Since it is lying on HP, obviously that point should be on XY line in the front view. So you mark that point P dash on the XY line. So that is what it is evident from here also. That is from here also. Then you mark that point as P dash. 20 mm behind VP. Behind VP is always seen in HP. So that is, when you look from the top view, this behind VP is always seen in the horizontal plane. So you measure a distance of 20 mm and you mark this point here and you mark this point as P. And then draw a 45 degree line adjacent to HP, because in the profile view I can see the distance of both front view and as well as the top view. So you project that front view onto the profile plane by drawing a line here. So since I want to project the top view, so draw a 45 degree line adjacent to the top view. So draw a 45 degree line adjacent to HP, because the top view image is seen in HP. So because top view is perpendicular to HP. So from the origin, you measure an angle of 45 degree by using the protractor and you draw a thin line. Then project the top view point onto that 45 degree line. What happens? This 20 mm which was vertical here is transferred to horizontal distance. Then draw a line from this 45 degree line to the XY line in the side view. And you mark that both these two points, both these two lines will intersect at this point. You mark this as P double dash. Since it is behind RPP, therefore it is called as the right side view. So which quadrant on which you are being able to project? It will be projected on this point P lies in second quadrant. You can see here the point P is in second quadrant. Now we will going to take up the another case. What is that? Since it is behind VP and on HP, so we will consider the third quadrant now. When we are considering the third quadrant, you can see the HP here and this is VP here and this is the right profile plane. and all other things will going to remain the same. So as we know that the distance with respect to the profile plane, which is 35 mm, is seen in VP, that is on this plane, and also on HP, that is on this plane. So that means you have 35 mm behind RPP. And since it is lying on HP, obviously that image, when you look from the front view, is projected onto the vertical plane, which will going to be small p dash. Then as we look from the top view, the image will going to fall on the horizontal plane. So that is on HP. Since the distance given is 20 mm behind VP, so from here you measure 20 mm and you mark this point small p. And now as we see from the profile view, since it is behind VP, always it should look from the right side view. The image will going to fall on the RPP. So as we see here, you draw a projector from the top view here to this line, and you draw a projector from here, and then it is projected here, so that both these two lines will going to intersect at this point. You mark that point as P double dash. As we cut here and open that HP to the top and RPP to the right side, you can see that it has been projected like this. So correspondingly, the image is also being rotated. That means VP will be below XY line and HP will be above XY line, and RPP is always adjacent to the vertical plane. And as we know that the distance with respect to the profile plane, that is behind RPP, is seen in VP as well as in HP. So from this line, you measure a distance of 35 mm and you draw a vertical projector. Since it is lying on HP, obviously the point is in VP. Since the image is in VP, so obviously it should be small p dash. Then behind VP, which is 20 mm, is seen in HP. So obviously you mark this point as small p. As we can see in the profile view, we can see the distances of the front view and as well as the top view. The front view is lying on HP. Obviously it will be on VP. So obviously that line will also be the same on the profile view. So you draw this, the image will going to fall, comes here. As the distance with respect to VP, that is behind VP, which is vertical here, as it has been projected till here, you are going to get still it is vertical. When you draw a line inclined at 45 degrees such that it will come to the profile plane, then this vertical distance is transferred into the horizontal distance, and you mark this point as P double dash, and the view what you will going to get for this will going to be the right side view. So when you are trying to take it from the orthographic projection, here first we will go to draw the XY line and X1 Y1 line, which is little bit thicker than the projector line. Then first identify the plane. Since it is in the third quadrant, HP will be above, the vertical plane will be below, and RPP will also below. And we know the distance with respect to the profile plane, which is X1 Y1, which is 35 mm. From X1 Y1 line, you measure 35 mm and draw a vertical projector, which should be a thin line. Since it is lying on HP, obviously that point will be on VP. So you will mark this point as P dash. Then the distance behind VP is seen in HP. HP is above XY line. So from here you measure the distance of 20 mm and you mark that point as small p. Then you draw a 45 degree line adjacent to HP, because I can see the distances of both the front view and also in the top view. So you project the top view, front view point directly to the profile view. And since I want to project the top view distance of 20 mm, so from the origin, by using the protractor, you measure an angle of 45 degree and then draw an inclined line. And this should also be thin line. And draw a top measure from P, you draw a horizontal projector which will going to cut this 45 degree line. Then what happens? The distance which is vertical here, which is 20 mm, is transferred into the horizontal distance. And from here you draw a vertical projector such that both these two lines will going to intersect at this point, and you mark this point as P double dash, and the view what you will going to get is the right side view. Since HP is above, VP is below, and RPP is adjacent to VP, so obviously it will lies in the third quadrant. If you observe both the figures or both the orthographic views of the second quadrant as well as the third quadrant, the sketch remains the same. Only the difference is the HP, VP and RPP. In the second quadrant, HP, VP will be above XY line. Since VP becomes above XY line, therefore RPP will also go to the above XY line. But all the other locations of the point will going to remain the same. Similarly, in the third quadrant also, the locations of the points will going to be remain the same, except that the planes HP is above, VP is below. Since VP is below, RPP will become below. So this is how you will be able to analyze this problem. Whenever the problem is given in the examination for these type of things, either you can write it is in second quadrant or it can be shown in the third quadrant, but you have to mention that the point capital P lies in second as well as third quadrant. And this is how you will be able to analyze this problem. Thank you.